Now we are live, and let me tell you if you have any doubts in the middle of solving these problems, please let me know. Without any delay, let's start solving this problem. Let me change it like this. Okay, that's correct. 1 second. If we see the question, the first question was pretty simple. We are given with prices, we are given with discounts, right? These are the two things. Now, one discount for one item, right? That means you can use discounts of I for just one time, not more. I hope you understand. One item or price of I you can apply. Now, apply discounts optimally. Uh, Apply discounts optimally, optimally, such that you get minimum possible sum. You get minimum possible sum. Let me tell you here, just imagine. We have prices as they have told us 10, 30, 21. And we have discounts like this, 50 and 60. Let me tell you, if you are having something like this, then what would you do? First thing, if I was in your place, anyone it might be, we would do one thing. We would do one thing. We just, just let me tell you, we have 60, right? We have 60 as the discount. We can use it. Will I use it on 10? No. If I use 60% of discount, then this would be 4. If I use 50% of discount on 30, then I would get something like 15. Just imagine instead of doing like this. No one would be doing like that. Now, instead, I have 60, right? That's the greatest discount I can apply. So the greatest discount goes to the biggest price, the biggest discount for the biggest price. So 60% of 30 will be the discount. So I think I should pay 60 with 30. Now I have 50. Just look at this 50. I have this 50% discount. Now, where would I apply it? On 10 or 21? If I applied it on 10, I would just get 5. Okay, that's a minimum. But if I applied it on 21, I think 10.5. Now, if I applied it on 10, the price would be 5. So the remaining would be 5 plus 21, which is 26, right? If I applied it on 21, I would get 10.5. 10.5 plus 10 would be 20.5. So that means every time you see a greatest number, match it or apply the discount with the greatest price. That's it. Greatest discount for biggest price. That's it for the first one, biggest price. So how do I apply it? You know, the prices would be less size or discounts would be of much size. So what I would do is first step, sort both arrays, both prices and discounts, discounts in decreasing order, right? So apply discounts like this, iterate and apply, iterate and apply discounts and add to the answer. And the remaining which are left over, add to the answer. So remaining which are left, if there are anything left, if there are anything left or remaining in prices, add it to the answer, add to answer. So I'm just writing the algorithm here. So the algorithm goes like sort prices and discounts in decreasing order, right? That's the first step. So iterate for I is equal to 0, I is less than minimum of prices dot size and discounts dot size. Apply discount, that's it. Add answer plus is equal to how I wrote it is final price becomes this, right? So imagine final price becomes this, right? So prices of I into 100 minus discounts of I, that's the whole thing, by 100. But our answer needs to be in the data type of double. Double answer is equal to 0.0, right? So answer is being incremented, that's it. Return answer at the end. But before that, if there are any prices left over for SZ and SZ is less than prices dot size, SZ will be incremented and answer plus is equal to prices of I. Please be careful when you're doing this addition or subtraction when there are two different data types. So what I did, I kept double for everything. That's it. Return the answer at the end. Every time I want to write the code, I'll just write the algorithm. I'll just end up writing the code. Okay, I think we are good to go to the next problem. And if you have any doubts, please let me know. I'll just give you 5 minutes to ask your doubts. However, so I think we have completed this problem, the first problem, even explanation in just how many minutes? 5 minutes. You can ask your doubts, right? We'll just wait first of all. We are just waiting so that anyone who are new to this channel or new for this live stream, they can just ask their doubts, right? So we'll just wait for 5 minutes. Hi, Devendra Bhai Parmar. Right, that's a good thing. So we're gonna go and solve the second problem. Thanks for attending this live session. So, question number two. That's great. We have completed. Wow, this was a good problem. Let me tell you how I solved it. Solve this with taking an example. We have 0, we have 1, we have 2, we have 3, 4, and then 5. Don't see this as any tree. See this, look at this as a graph. So the first thing is I have -1 triple zero double two, right? -1 triple zero double two. What is this saying? Parent, right? So parent of 0 is -1. That means there is no parent for node 0. 1, 2, 3, 4, 5. So 1, 2, 3 have parent 0. 4 and 5 have parent as 2, right? What I'll do, I'll just construct a graph. Construct a graph by using parent array. Why I'm constructing this graph? I think I have to explain this. I'm just changing the way I'm explaining. I have 1, 2, 3 with the parent of 0. So what I'll do if just I have stored 0 is having the children like 1, 2, 3, and 2 is having the children like 4 and 5. How it would be? It would be better, right? Only one way, one directional graph. So this is something calling it as graph, right? Now I'm at 0. What if I figured it out? So the way they are asking the question is I have 0, right? Now your task is the weight of a node I at depth D. They said there will be some weight, right? We need to calculate some weight of every node. But before that, at depth D, what does this depth D mean? I'll tell you. Depth of a node is the number of nodes on the path from the root to that node, inclusive with the root having depth 1. So the depth of this is what? Depth of this is 2, 2, 2, right? So here it will be 3, here it will be 3. Now, what is the height of this tree? The maximum depth among all nodes in the tree. If you see all the nodes, from this, the maximum is 3. Max is equal to 3. So the height of this tree is equal to 3. That's it, right? Nothing much, but saying it orally is, if you have said it orally, what is being asked, what we need to find out. Then, if you just know the algorithm or approach, it's just easy. But figuring out orally what we need in the problem is the toughest thing. We might know trees, graphs, DFS, BFS, everything. But the hardest part is to explain what is being asked and how we can go with the approach. So I got to know, I have height, I know what is the depth, right? So what I'll do is I want to store depth of every node. Let me tell you how I would do that. Depth of every node. Let me tell you, if I started at 0 and you know I am starting at 0 with the depth of 1. So imagine I have the node 0 and the depth 1. Node comma depth. Then if you see here, this 0 comma 1. I got 0 is connected with 1, 2, 3, and 2 is connected with 4, comma 5. This is the graph I have. Now, I have 0 with the depth of 1. The connected ones, zero, 1, 2, 3, 4, and then 5. The connected things like this is having 1, this should be 2. This should be, sorry, 2. And this should be 2. So everything which is connected to 1, the downward will have 1 plus 1. The current one plus 1. So I would take that as current depth is equal to 1. The connected nodes to this 0, this node, the neighbors are 1, 2, 3. So 1, 2, 3 would have the depth of current depth plus 1. So what I would do is store depth is equal to for I have 0, 1, 2, 3, 4, 5. For 0, I already know it is 1, right? I'm just updating it. Now, this node 0 is having the neighbors 1, 2, 3. So what I would do is 1. What is the depth of 1? Current depth plus 1, right? So 1 plus 1 would be 2. Then I have 2, the node 2 comma 2. Then I have another node 3, 3 comma 2. I'm just pushing back into the queue, right? Now, the current depth will be 2. I'm just taking the front one, 1, right? So if you see, 1 is having no children. That means there is no downward nodes for 1. There is upward, right? There are no children for 1. So there need not to be any depth for 1. I'm just calculating the depth with this, making in an array so that if we have the depth, we can have the maximum depth, which is nothing but the height. So we can have the maximum depth as height, and we can just get weight of node I at depth D is nums of I into h minus d plus 1 h I know, and we are calculating D, and we are going with nums. We just need to do a simple thing. We already know nums of I, we are just calculating all the depths, right? So that's it. That would be a great idea. Now the current depth is 2. Let me take the another one, 2 comma 2, right? I'm just taking it. For 2 comma 2, I have 4 and 5 as the neighbors. So 4. The depth of 4 will be 2 plus 1. 2 plus 1. So ideally here it will be 3 and 3. So 4 with the depth of 3. Depth of 3. And then again I have 5. So 5 comma 3. I think you got it. Now I'll go here 3 comma 2. That's the current node. So the current depth is still 2. But the node is 3. Does 3 have any neighbors? No, not at all. Let me take 4 comma 3. If you see, I'm just changing the current depth 3. Right? Is 4 having any neighbors? No. Then I'll just have 5. Right? Is 5 having any neighbors? No. So the current depth has become 3. Right? From all these 1, 2, 3, every time I get a current depth, I'll just update max depth. And let me know if there is any time you're not catching up what I'm saying. Right? This is just a tree problem where we just store the depth. So, what are the depths I have found out? For one, I have found out two, here two, two, and then here three, and then three. So, nums is equal to 5, 2, 3, 1, 4, 6. Now, I have 0, 1, 2, 3, 4, 5. These are the nodes, right? So, weight of a node I at depth D is nums of I into. So let us calculate for this. Nums of I into, let me write it, nums of I into h minus b plus 1. So nums of I is 5, right? Into, what is height? Height is maximum depth. What is the maximum depth? I got 3. So that's constant. 3 is constant. What is the d? Depth at I, node I at depth d. Depth is where I got it, right? So depth of I, that's what I need. Depth of I, which is depth of 0 is 1, right? Plus 1. So here also I think we need depths of I, right? So we can also write it like this. So what I would get, 5 into 3 minus 1 plus 1, that's it, 3. 5 into 3, 15. 15. We got it correctly. So that's how you solve this. I think you got it. So the algorithm goes like this. Algorithm goes like this. First, construct a graph like this. I have 0, 0, yes, 0 with 1, 2, 3, and 2 with 4, comma 5. That's just one directional. You can use as per your language list of list, or here I have used unordered map, right? Okay, we have the graph. Now what we'll do? We'll just do BFS, but before that, let us take max depth as 0. Now let us create depths of size n, which are all are having 0. Now depth of 0 will be 1. These are the three things which I would initialize. So depths n comma 0 is nothing but vector of int, vector of int. Now depths of 0 is 1. Now let me tell you, I only have for this. How do I get for all of this? So for that, I'll initialize q of a pair, where I would have int, comma int. I would have the node, I would have the node and the depth. So q dot push, the first depth I know, first node I know is 0 and the depth it is having is 1. So q dot push this, that's it. Now while this is not empty, while the queue is not empty, we'll do one thing. We'll just take auto node comma current depth is equal to q dot front, and we'll just remove that from the queue. Now we'll have the neighbors, however, for auto neighbor in graph of node. We have the neighbors now. But before that, we already got a depth, the current depth. So let me update it. Update the maximum depth. So max depth is equal to max of max depth, comma, current depth, right? So here, when I'm pushing this q dot push, the neighbor and 1 plus current depth, right? So that's all I think. So let me tell you, here we also have this depths array, right? So what we do is depth of node is equal to current depth, right? So at the, we'll just iterate I is equal to 0, I is less than nums dot size I plus plus. will have answer is equal to 0. So answer plus is equal to here. We got nums of I into what is the h? H is max depth minus depths of I plus 1, right? Return the answer at the end. Okay, I think we are done with the second one. Let me show you my submission. Right, so here it is. Ravindra. It's okay. Thank you, bro. Thank you, Devendra Bhai Parmar. Thanks for attending this. I think it's not visible. No, it is.